Okay, class. In this video, we will be talking about Unit 10. The name of the unit is Oscillations and Waves. And in this video, we will be talking about some part of this chapter, which is called Simple Harmonic Motion. And it will be, I will advise you to pay close attention to it. If you listen to it carefully, you will understand it. Okay, it's not difficult, it's very easy. Now, firstly, we will talk about periodic motion. What the term periodic motion? What exactly is periodic motion? Periodic motion is those kind of motion which repeats itself over and over again after a regular time interval. Okay, I will not write everything because it will consume time. So periodic motion are those kind of motion which repeats itself over and over again after a regular interval of time. For example, the movement of the earth while revolving around the sun, that is a periodic motion, right? It takes 365 days. Similarly, when we move a pendulum, okay, I hope you know what is pendulum. When a pendulum takes regular interval of time from its mean position, this is called the mean position. Okay, the center is called the mean position, and this the extreme ends where the bob of the pendulum moves. It takes a regular interval of time. Okay, it may take 2 seconds or 3 seconds or whatever. So that motion is also called periodic motion. Those are the few examples that we can give. Now, secondly, let's talk about oscillatory motion. Oscillatory motion is almost the same with periodic motion. Oscillatory motion, the motion that repeats itself over and over again after a regular interval of time about its mean position. Okay, the motion repeats itself over and over again after a regular interval of time about its mean position, such that it remains confined within true limits. Okay, like for example, this pendulum moves about its mean position up to this point, the extreme limit from the left side is this point, right, and the extreme side is to the right side is this point. So it moves in this motion. So this kind of motion which repeats its motion over and over again after a regular interval of time about its mean position within true well-defined limits. Okay, within true endpoints, that is called oscillatory motion. So the best example which we can give is again the bob of a simple pendulum. Okay, this is also an example of oscillatory motion. It is also an example of periodic motion. Okay, but the earth revolving around the sun is not an example of oscillatory motion because it is moving in circular motion, right? There is no two endpoints in the earth moving around the sun. So in the bob can be both example for periodic motion and oscillatory motion. Now let us give a few definition of some terms. Time period. Time period, we just represent it by capital letter T. The time period is the smallest interval of time after which a periodic motion completes. Okay, that is called completes itself. That is called the time period. For example, the time taken by the earth to revolve around the sun, that is a time period for the case of periodic motion. Okay, so for the case of oscillatory motion, the time period of an oscillatory motion is defined as the time in which one vibration is completed, right? For, like I said, when the bob moves from this end, from this extreme right side to the extreme left side, that time period to complete one rotation or one vibration, that is called the time period. It is simply represented by T. Now again, let's go to another term, which is frequency. QUENCY. Okay, frequency, it is represented by mu. Okay, so the number of vibrations that occur in a particular time, in a unit time. Okay, so it means that if a ball is rotating in circular motion and the number of rotation that the ball makes in 1 minute, okay, that is called frequency, or it can be 1 hour or 1 day or whatever. Okay, a unit time. Okay, so the number of vibrations that occur in a unit time is called frequency. It is denoted by mu, and the formula is mu is the frequency is equal to 1 by t. Okay, and it is measured in hertz. Okay, the frequency is measured in hertz. The number of vibration or rotation that a body possess in unit time. Okay, that is frequency. Now let's talk about another final term, which is displacement. Displacement can be defined as the displacement of a particle at any instant is the distance of the oscillating particle from its mean position at any instant. Okay, for example, if the bob is moving from this mean position, and in 1 second or in 1 millisecond, if the bob is reaching up to this point, okay, so the distance traveled by the moving particle or the rotating particle or the oscillating particle, the distance moved by the oscillating particle at any instant, it can be at 2 seconds or at 3 seconds or in a millisecond. If we take any second, any time, the distance traveled by that particle, by the oscillating or rotating particle from the mean position, that distance traveled at any instant is called displacement. Okay, now we'll go to some important derivations. We'll go to the main topics. These are just simple terms, okay, which you can understand and use your own words if it comes in the exam also. Now we'll go to the derivation. The first is periodic functions. Periodic function. You have studied in high school in quadratic equation. How do we represent? What is the general equation to represent a quadratic equation? We normally represent as f of x equal to ax squared plus bx plus c, right? This is the general equation for quadratic equation. This I hope you remember in which you studied in class 9, right? Just like that, suppose an object is moving in a circular motion or a periodic motion. Okay, suppose that a periodic motion is represented by it will has its own general equation. Okay, periodic motion will have its own general equation. It can be represented by either using sine function or cosine function or sine function. A periodic motion can be presented in these two ways. So there will be time, right? Time will be always existing. So suppose if we represent a periodic function, a periodic motion by sine or cosine function with time, okay, with the passage of time. So let those two general equation of the periodic function be, of the periodic motion, let that be just like this. Okay, just like we represent the quadratic equation, we can represent the periodic motion like f of t equals to sine 2 pi by t into t. Okay, or we can also represent it with cosine function. Okay, it will be cos 2 pi by t into t. These two are just the general equation to represent the periodic motion. Okay, just like we represent the quadratic equation like this. So let's give this equation 1 and equation 2. And here, what is t? Capital T, capital letter T is the time period of the periodic motion. Okay, now, and each of these two equation will, each of the two repeats itself after a time t. Okay, each of these two values will repeat itself after time interval t. Okay, capital letter T. Now if we increase the time, this time by small amount t. Okay, so if we increase the time t from, if we change the time t from t plus t. Okay, if we replace this small time t by this t plus t, then how will these two equation come out? Then this f of t will be t. So if we rewrite this equation, okay, if we rewrite this equation, it will be f of t, if we change it to t plus t, okay, we increase the time, okay, we increase the time interval. So if f of t plus t equal to, so if we, it will be sine 2 pi by t. If you look at this equation 1, this t will increase, right? So this one will become t plus t. So if we open the bracket, it will be sine 2 pi by t into t. Okay, I multiply this one. I multiply 2 pi by t with t and t. Plus, if we multiply 2 pi by t with this capital T, get this 2 capital T will cancel, right? This 2 can cancel, so it will be only 2 pi this time. 2 pi. Now, there is one formula in mathematics. There is one formula in mathematics which is sine theta plus 2 pi, right? Sine 2 pi plus theta is equal to sine theta. Okay, this you studied in class 11 mathematics in trigonometry. So we will apply this equation. So theta is like 2 pi by t, right? And this 2 pi is this 2 pi. So if we apply this formula over here, then we can have f of t plus t is equal to sine 2 pi by t to t. Okay, we use this formula. I hope you understand this one. If you don't understand it, just screenshot it and study it. Take time to understand. Okay, now if you look at equation 1, this is same as equation 1, right? What is equation 1? F of t is equal to sine 2 pi by t, capital T, t. So this is same with the equation 1. So we can write f of t plus t is equal to, if you look at equation 1, this ft, right? So we can write it like ft. Okay, now similarly, if we replace t with t plus t in equation 2, okay, if we follow the same step, similarly, I will just write similarly. Okay, we don't have to show all the steps now. So similarly, if we replace this small, if we increase the time t with t plus t in equation 2, just like this, we can get g of t plus t will be equal to gt. Okay, this is what we can get if we apply it again, the same process in equation 2. Now, even if t is increased to any number, okay, even if this time interval t is increased to any number, then the two equations, okay, this equation and this equation, we can get it like f of t plus t, right? So even I will not write the words, okay, even if t is increased to any number, okay, if the function defined by these two equations, it can be easily verified, okay, even if time is increased to any number, to any value. So we can have f of t plus and t is equal to, here I rewrite it, okay, if t is increased to any number equals to f of t, and just like that, g of t plus and t will also be equal to g of t, where n is equal, n can have values 1, 2, 3, any natural number. Okay, so it will still be the same even if the time interval is increased. Now I will talk about some other separate things. Okay, this is one group. Hemi hi adifituna kan derive na hlom khat de wan etuna hemi zom na tho si hi hlom shang. Okay, it is still the continuation, but we will talk about some another different way, and we will say it in different way. Okay, a few more useful periodic function can be there. In the beginning I said that these two are the periodic function to represent it, right? And there are few more other periodic functions which we can represent it in cos and sine. Okay, we can also represent periodic function using cos and sine in another way. Okay, so those two ways are f of n t is equal to 2 pi. It is almost the same, okay, 2 pi n t. I am just adding n, okay, n over here and n over here. And similarly, let's give this equation 3, okay, and similarly g of n t is equal to g of n t is equal to sorry, I forgot to write sine. Okay, there is sine 2 pi n. Here let me write sine. And for cos, I will also write cos 2 pi n by t. This is small letter, okay, t. Now let's give this equation number 4. Now where n is also here, n can have values 1 2 3 dot dot dot. It can have any value, okay, so it can be verified that for just like before, okay, using all of these steps just like before, from in the first step, from these two equation we are getting this and this one, right? So just like that, from these two equation we can also verify that f of n t here, f of n t plus nt, okay, this time it will be f of n t plus nt will be equal to I don't have to write n, okay, equal to f of t, but we don't have to show these steps, okay. Hemi step hiti lan ve khatul to lowa mami ang khan hemi equation pani tang ve thong hian mami te ang thawin hetiang ang hi a mu chhuat heye ti kha soi ani mai a chuwang chuan a step zong zong an kan mu chhuat dana kha soi lan ve khatul to lowa hemi n hu f of t le g of t la ya khwan n khu tel zeu kha ni mai a, and the answer will still be the same, okay, f of nt and gn t. So where n can have values 1 2 3 dot dot dot, okay. So even if we use this equation to represent the periodic function, we are getting this and this. And if for any number of particles, okay, for any n number of particles, we will use this two general equation, so we can get the same result, okay. It is still the same with this and this one over here. Now we will go through, that is our one case, okay, that is our one case number 1. And for our case number 2, there is, like I said, this topic is concerned with simple harmonic motion. Right here also I have written simple harmonic motion. And simple harmonic motion, what exactly is simple harmonic motion? I will just write the general equation, okay. The derivation is not necessary, okay. It is not necessary, it is not important to derive the general equation for simple harmonic motion. A simple harmonic motion, or we can simply write it SHM, okay, capital letter SHM. It means simple harmonic motion can be represented by a function f of t is equal to a1 cos 2 pi by t plus b1 sine 2 pi by t. Okay, this is how we represent the simple harmonic motion of a periodic function. Like I said, we don't have to study the detailed derivation. This is just the equation, and where a1 and a2 are Fourier constants, okay. These are called, a1 and a2 are called Fourier, Fourier coefficients, okay. They are called Fourier coefficients, and it can have any value as long as it is non-zero, okay. These two Fourier constants, Fourier coefficients, should not be zero. As long as it is non-zero, it can be correct, okay. So a1 and a2, it can have any value. Now that is all about periodic function, okay. Now we'll go to the next topic. Now we will utilize this equation for the next topic, okay. Ito na next topic kan derive le nga chumi derive chumi manna chumi tura chuan hemi simple harmonic motion hi hemi hi kan mangtang kai chunjom le ngal pop don tani. So the next topic is periodic function representing simple harmonic motion, okay. Periodic functions representing simple harmonic motion. Okay, periodic functions representing simple harmonic motions. Now, like I said, the simple harmonic motion is represented by the function. I will write the equation again. F of t is equal to a1 cos 2 pi by t plus b1 sin 2 pi by t. Okay, before I continue, I would just like to say that when you look the video and study it, don't just look at it. If it is possible, write it along with me, okay, so that it will be easier for you to understand and to memorize. In ngai thak pa kan in ngai thak ringo ta hetia ka jin en ringo chon boring in tivat do na video rei thei sia in ngai that wan tling pe thin lawang ti ka hlawa chuan paper velovin chopula ka ji ang khati khan zia kula thu te po khati khan in man le lo ziak tel ula ka ra je tur zeu zeu kha all sampha bokang o en top ai chuan o mi ti sa khami ka video en top ai chuan kasoi pa zel khalo ti ve zel ula ti khanin zir pa ni ngal zel o video that ve na ni ta na kin zel apo in revise le du hona apo video khan en le zeu menga ti khan lo ti pa ve khan in tan all sampha don o en top ai chuan chu ka advice zeu ni chu. Now, however, like I said, a1 and a2 are Fourier coefficients and it can have any value except 0, right? So for our proper calculation, okay, proper choice of coefficient a1 for our proper choice for a1 and b1, okay, the proper value which we can take for good calculation is for the first case, okay, for the first case, if a1 is equal to a cos phi, okay, and if we take b1, the value of b1, if we take it as minus a sin phi, okay, so these two are the proper choice to take a1 and b1 for proper calculation to get proper result, okay. So if we take these two equation, then we will just solve this. How will we get a square, then a square cos square phi, a square cos square phi plus a square sin square phi. How will we get this one? Okay, we are squaring, okay, we are squaring both sides and adding, okay, I am squaring and adding both sides of these two equation. A square cos square phi plus a square sin square phi. Since it is square, this minus will become plus again, right, and will be equal to this a square cos square phi is a1, right, a1 square. We are squaring and adding both sides, okay, of this two equation. So a1 square plus b1 square, right, b1 square. It is simply squaring and adding the above two equations, okay, this a1 equal to this and b1 equal to this. Now I will take a square common, okay, a square, if I take common, a square phi plus sin square phi equal to a1 square plus b1 square. Now I hope you know this formula. Sin square phi plus cos square phi is 1, right, the value of this is 1. So it will be simply a square is equal to a1 square plus b1 square, or a is equal to root over a1 square plus b1 square, or instead of root we can also write a1 square plus b1 square to the power half, okay, instead of root we can write to the power half. Now we will also take the value of tangent, okay, we will take tan value, tan phi. What is tan actually? Tan is sine by cos, right, tan is sine by cos, so it will be this sine value by cos value, right, a cos phi. So here a and a can cancel, so actually it is minus, here we still have minus, right, minus b1 by a1, right, sine by cos will be b1 by a1. So tan phi is also equal to minus b1 by a1, or if we want the value of phi, then this 10, we cannot write it like a1 by b1 by a1 by 10. Okay, it does not have any meaning. Okay, if I shift it down, instead of writing like this, we should write it like 10 inverse. Okay, 10 inverse minus b1 by a1. Okay, a phi la ya hi kan du chuan 10 chuk thlak ti ringot khom ziom lowa 10 inverse ti ang zong hian zia thin tur ani a. Then there is one formula in mathematics, 10 of minus theta is 10 theta minus 10 theta, right? This you studied in trigonometry. Okay, mets la lawin nom no langa mizo la inom mga har sin ti de me thaya kan formula man nang chun chun hi lo shave top mero kan man nang ang hi chu. So this minus can be written at the beginning. Okay, so phi is equal to minus 10 inverse b1 by a1. Okay, now this is just the formula. Okay, now if we substitute, let's give this equation 1. Okay, the main general equation for simple harmonic motion, let's give it equation 1. Now if we substitute in equation 1, okay, if we substitute the value of a1 and b1, okay, then what will we have? In equation 1, if we substitute the value of a1 and b1, we will have f of t is equal to, what is a1? We take it a cos phi, right? So a cos phi, and this I will copy it just like as it is. And what is b1? b1 is minus a sin phi, right? So I should write minus, right? Minus a sin phi, and b I write minus a sin phi, and so sin 2 pi by dt. I will copy it again. I'm just putting the value of a1 and b1. Okay, I'm putting this true value over here. Okay, so sin 2 pi by t. Okay, now hemi video kan derive how hi angamon it per hi chu exam na tha trama po aron chuak le theini mark li pu velin to chin lo ngai pai mo don ne bekin he video hi. Now first I will take for the next step, I will take a as common factor. A cos phi cos 2 pi by dt minus sin phi sin 2 pi by dt. Okay, I'm just taking out this a as common factor. Okay, common term. Now there is another formula in trigonometry in your maths. What is that formula? I will write the formula over here. Okay, cos a cos b. Okay, cos a cos b minus sin a sin b is equal to cos a plus b. Okay, this is the formula in maths. Cos a cos b minus sin a sin b. A hita hian phi yang hi nia. A is phi, b is 2 pi by dt. A phi, b is 2 pi by dt, right? Cos minus sin formula. So I can put it in this way. Okay, cos a plus b. I will just write it like that. So I will be f of, this is still f of t, right? F of t is equal to, I will just write it like cos a plus b, right? So it will be cos, what is a? A is, we can choose any one. Okay, a can be this or this. Okay, so since plus on it hawa hadik don thawa ngapo hiziak masaila, so I will write this 2 pi by t first. Okay, a plus b, 2 pi by t plus phi. Okay, phi I will consider it as b. Now that is the first case. Okay, that is the first case here. It is the first case if we choose these two value for a1 and b1 for Fourier coefficient. Okay, now suppose if we take another value for the Fourier coefficients a and b. Okay, if we take a1, as a sin phi, okay, and if we take b1 as a cos phi, okay, so I will not show all the detailed steps this time. Okay, hang lai step zong hang lai root over ania hemi value to hikaziak to pang oh. If we take these two value, then just like this, our value of a will be just like before, just like the previous step. Our value of a will be to the power half. Okay, it is still the same. Okay, and our value of 10, our value of phi. Okay, this value, our value of phi will be in this condition. In this case, our value of phi will be 10 inverse a1 by b1. Okay, we don't have to show all the detailed step for this one. Okay, we will just write similarly like the previous step. Okay, now if we will substitute for the value of a1 and b1 in this equation 1 again. Okay, just like this step. Okay, if we substitute the value of a1 and b1, so hemi step hichukati kan tichip chiar le deu kanga. So a1, if I write a sine phi, okay, a sine phi cos 2 pi by dt, cos 2 pi by dt, plus for b1 we take a cos phi. Okay, a cos phi sine 2 pi by dt, sine 2 pi by dt. Now just like before, we will take out a as common factor. It is sine phi cos 2 pi by dt plus cos phi sine 2 pi by dt. Okay, I'm taking out a as common. Now there is another formula in just like this one. Okay, hetiang type deu khan formula chidang kha met sa omleta ni, that is sin a cos b plus cos a sin b is equal to sin a plus b. Okay, this is another formula which we apply for this next step. Okay, so if we apply this formula, if we this form is this form. Okay, itiang hilaw ni ta chuan teng kan sia kanga. So it will be sin 2 pi by atira ma sa ka cos ania to na chon sin 9 tha ka chu ni mai oh ame thotain ang reng first case nen kha no harlo. So this, let's give this equation number, let's give this equation 2. Okay, and let's give this equation 3. So this is just the derivation, okay, of the periodic function representing simple harmonic motion. So these two equations can both be used. Okay, there are different notes, there are different there are a few steps you should memorize. The first is that f of t. Okay, this f of t, this equation. Okay, this gives the displacement of simple harmonic motion. Okay, this equation gives the displacement of simple harmonic motion at any time. Okay, and the maximum value of sine and cos, is 1. Okay, the maximum value of sine or cosine function is 1. So from this equation, it follows that what does it implies? It means that the maximum value of displacement is a, and it is called the maximum value of displacement is called the amplitude. Okay, the maximum displacement it can have is amplitude. Okay, and if you look at these two equations, our final two equations, equation 2 and equation 3, this part written in the bracket 2 pi by dt plus phi. Okay, this part is what we call the phase. Okay, phase is what is the 2 pi by t plus phi. This part is called phase. Okay, if you look at these two equations, and 2 pi by t part only. Okay, this part 2 pi by t is what we call angular frequency. This we studied in first term. Okay, so 2 pi by t is called angular frequency. It is represented by omega. Okay, this is not w. Okay, this is omega, and it is represented by omega, and it is called 2 pi by t is called frequency. So we can also rewrite these two equations as, if we are going to write it in terms of omega, so this 2 pi by t is omega, right? So it will be omega t plus phi, or f of t is, if I rewrite this in terms of omega, I forgot to write this small t, omega, so it will be sine omega t plus phi. Okay, so these are just the few extra points. Okay, it may not be necessary to write everything in the exam. Okay, the important thing is up to equation 3. Okay, so we will solve one question here. It is very easy. I write it over here. A simple harmonic motion is represented by f of t is equal to 10 sine 20t plus 0.5. Okay, so write down its amplitude. That is the first question. So what is amplitude? How do we get it over here? F of t is equal to sine omega t plus phi, right? So if I rewrite it in the form of equation, f of t is equal to sine omega t plus phi. Then comparing this, if we compare, oh, I forgot something again. Here I take out a as common factor, right? So I forgot to write a over here, the common factor. Sorry for the inconvenience. Here also we take out a common factor. Pero hemi light chin hibra formula kan apply na chin khan ya. A hi kalau zia the a ka kalau mai ni hi. Oh, so the a should also be there. So here the general equation is a sine omega t plus phi, right? This is the equation. Okay, f of t is equal to 10 sine 20t plus 0.5. So our general equation is f of t is equal to a sine omega t plus phi. Okay, so the first question is asking us write down its amplitude. Okay, so amplitude is, if we compare these two equations, this a. Okay, so a is amplitude, so a is 10. Okay, a is 10. Very easy. Okay, it is measured in terms of meter. Okay, 10 meter. And angular frequency is asking us again. Angular frequency is omega. Okay, omega is angular frequency, omega t. So here it is 20t. So the angular frequency is 20. Okay, and it is measured in radian per second. Okay, radian per second already. Okay, radian per second. And again it's asking us frequency. Frequency is, we have to solve it a bit. Okay, frequency is and the other, like I said, frequency is 1 by t, right? But time period is not given here, capital T is not given. So another formula for frequency is omega by 2 pi. Okay, if we use this, then we will have 20 by 2 into 22 by 7, right? 2 pi. So if we solve this one, we will get 3.18. Okay, that is omega, and it is represented as hertz. Okay, H-E-R-T-Z, hertz. It is measured in hertz. So this will be the frequency, 3.18. And time period, the time period is t. Okay, so the time period, it will just be the reverse of frequency. Okay, so time is again 1 by mu, right? So mu we already calculate 3.18, so 1 by 3.18, so it will be 0.314. Okay, 0.314 second. That will be time period. And finally it is asking, it is also asking initial phase. Okay, initial phase will be this part. Okay, initial phase is 0.5. By comparing the two equations, this equation and this equation, the initial phase is phi. Okay, this phi is the initial phase, so this is 0.5. Okay, 0.5 radian. Okay, it is measured in radian, and that is very simple. Okay, now we'll go to our final topic for this video, which is uniform circular motion and simple harmonic motion. Okay, uniform circular motion and simple I'm having class 10 minutes from now. Simple harmonic motion. Now, let us consider a particle moving in circular motion in anti-clockwise direction. Okay, let us consider a particle moving in circular motion in anti-clockwise direction. Then let these two axes, x dash, x and o x dash and y o y dash, let them be perpendicular to each other, and they represent the diameter of the circular motion, right? And this is the center point of reference. Okay, this is the, and here if t is the time period of the uniform circular motion, I hope you know what the meaning, right? When your object is moving in circular motion with uniform speed, right? That is uniform circular motion. And in this case, the frequency is given by 2 pi by t, right? This we have also utilized it, and we have also explained it. Omega is given by 2 pi by t. Now, at a time t equal to 0, at time t equals to 0, at that instant, if the object is at point PO, okay, at this point, so, and if it makes an angle phi with the x-axis, okay, and at time t, at time t, okay, at time t, then then the object is moving up to a point P at time t. Okay, so let the distance traveled, let the angle be omega t. Okay, at time t, from time 0 to t, let the distance traveled, the angle be omega t. Now, from this point P, let us drop a perpendicular. Okay, we will draw perpendicular for both the axis. Okay, for both the x-axis and y-axis, and let it meet the x-axis at M, and let it meet the y-axis at N. So let the distance of OM be x, and let the distance of ON be y. Okay, so this will be the required figure. Now, what will be, we will consider this right triangle OMP. Okay, in right triangle OMP, what will be, what is the angle? The angle is omega t plus phi, right? The angle is omega t plus phi, this total angle, right? Omega t plus phi. So what will be cos omega t plus phi? The total angle, it will be, what is cos? Cos is base by hypotenuse, right? Curly brown hair, that formula I have studied. So what is the base? Base is x. And what is the hypotenuse? The hypotenuse, let the radius of the circular motion be r. Okay, so the hypotenuse is r, right? X by r. So if we cross multiply it, it will be x equal to r cos omega t plus phi. Okay, now if we substitute this omega with this value 2 pi by t, then x is equal to r cos 2 pi by t plus phi. Okay, now it's very easy. Now let's give this equation number 1. Now similarly, if we look at the same triangle OMP, now instead of cos, we will take sine. Okay, sine omega t plus phi. What is sine? Sine is perpendicular by hypotenuse, right? Some people have. So the perpendicular is, what is the length of the perpendicular? It is y, right? So y by perpendicular by hypotenuse is r, right? R. So it is, if we cross multiply it, y is equal to r sine omega t plus phi. Again, if we put the value of, if we change the value of omega, with this 2 pi by t, then it will be 2 pi by t plus phi. So these two equations are the main equation for this derivation. Okay, what does this two equation mean? It means that the equation 1 and 2 are identical, are the same as the equation that we have already derived before. Okay, these two equations are same as this equation and this equation for periodic function of periodic function representing simple harmonic motion. Ti kan lo derive to masazo ka kan answer mo hey itason a ani maya a sine a cos 2 pi t by t plus phi. These two equations are same as the equation which we just derived over here. Okay, so these two equations we get it from what? Uniform circular motion, right? And these two equation we are getting it these two equation we are getting it from periodic functions, right? So what does that mean? It means that what does that mean? It means that the equation gives the equation 1, this equation 1 gives the equation the displacement of projection in uniform circular motion along this equation gives the projection this equation gives the projection along x-axis, and this equation gives the uniform circular motion of the motion along the y-axis. Okay, so simple harmonic motion may be defined as the projection of uniform circular motion along the diameters of a circle. Okay, hemi top nan in boy mate he to na ka conclude dan kha kaman mo de uhlek to atlas hey minute ngat no vel atlas kan ile nga ya kaman mo de uhlek ka rin ai na rei do viawa hemi equation hi a cos 2 pi by t t plus phi t le a sin 2 pi by t t plus phi t hemi equation pani hi hemi periodic function representing simple harmonic motion ti to thu pu yatanga kan derive kha anita simple harmonic motion kan derive na kha nita ni chonin he ta thil dang de tangin uniform circular motion he object atkal quality me me tang khan an pui che tho kha he cos 2 pi t by t t le sin 2 pi to nom yang tho kha he tlai mi te ang tho kha kan mu chuak le tho chuwang chuan uniform circular motion hi simple harmonic motion nen ain relate thei ain ang renge ti aron soi tumna ni me o tuna koron conclude dan kha chu in chiaranga note pdf in and post huna kha chu text atang te ponin lo chiaranga in thithiam me yang vai ji apo ngai lawa shortcut thiam kha ngai ve ne o. Now if for our final conclusion, if the object is at this point, okay, if the object is at this point a, okay, if the object is at this point, so there will not be phi, right? A ya chuan angle phi hi don lo. So if the object is at this point a, the angle phi will be removed, right? So we can have x is equal to, if you look at equation 1, r cos 2 pi by t is enough. Okay, no more phi, and y is equal to r sin 2 pi by t. Okay, so if the reference point of the circular motion starts from the point A, then according to these two equations, we can have these two. Okay, if it is along the axis, okay, there will not be phi. Okay, that will be enough. If you are a bit mixed up in la thiam lo chuan kaman mo de utla ka ngai en po har mei theya karet chuan ha chu private pon miron zot mei don ne o har sat na chuan mu nom lo viau mei theya ka ti deuh pop ka man mo bok nen.